All right, most of you took a quiz last Friday dealing with the basics of solving equations. Okay. Um, there were people that were able to get 100% correct on it, although I can say honestly that there were only maybe one or two correct papers all the way through all the classes. Most people missed typically between 2 and 4 questions, and it's not a real coincidence. Those questions on there were largely very common sense. Okay, you could know very little about solving equations and still be successful on that quiz, at least to the tune of a 60 or a 70 and possibly even an 80. Um, I did that on purpose, made some of those questions really very simple because, in all honesty, there are simple equations to solve that are out there. But if I had loaded the entire quiz up with the questions similar to like number 8 and 9 and 10, I'm not thinking we would have been successful. A lot of people were successful on the ones where they basically were able to sit there and plug in numbers. Okay, we said, okay, I really don't know how to solve it, but let's see what happens if x is 2. Let's see what happens if x is 3. Let's see what happens if x is 4. So we just kind of trial and errored it to death. My question is, what happens if x is negative 3.87? Are you going to be able to dumb luck and guess your way into that answer? Absolutely not. There's nothing programmed in our brain that would say, hey, try negative 3.87 and see if it works. Okay, so while a lot of people had no idea what they were doing on the first 4 or 5 questions, they were able to sit there and stare at it and just kind of plug in numbers long enough until they actually got it to work out. Okay, well, unfortunately, we are heading in a direction where that kind of strategy is not going to get us anything except for beaten up. Okay, as we've seen in geometry this year, and as some of you will see in geometry again next year, you may have to solve some equations that cannot be solved by looking at them or common sensing your way through them. Okay, and similarly, I wouldn't let you use your calculator on Friday. Okay, well, that caused a bunch of people a bunch of problems, and the reason behind that is really very simple. We're going to talk more about it here in a moment. We are in the habit of going to our calculator for a bunch of stuff that we have no business going to our calculator for, and it is causing us to have a severe inability to handle even the simplest things of mathematics. Guys, you are at a point, okay, here and potentially going on into Algebra 2, okay, where trial and error, plugging in numbers into an equation is not going to get you very many correct answers. And secondly, the calculator, as I've said so many times before, you're going to find this to be more and more true as life continues to go on. Calculator is only as smart as the person holding the calculator. If you cannot ask the proper question, then your calculator cannot answer the question. And as you go more and more forward, you're going to find that it is you that has to understand the question, not the calculator. Okay, so if you could not function on Friday without the use of the calculator, we need to overcome that. Okay, we need to deal with that, and that's what we're going to do. This week, we're going to be focusing on some of the basic stuff. Okay, square one, algebra one type things. We have got to be able to accurately and consistently solve equations without having the use of a calculator, simply because we know what has to be done. Okay, on Friday, you're going to face another test, and I guarantee you it is not going to be nearly as simple as the one that you saw on Friday. So if you were not able to get 8, 9, or 10 of those questions correct, if you don't make any improvement between now and Friday, Friday is going to be brutal. Okay, so let's take a look. Jot down some notes if you need to. Obviously, I'm going to do a recording. It's going to be on Edmodo, so if I end up going too fast and you need to review or catch back up, you can go on to Edmodo and you can check out the video. Okay, so here we go. Solving equations. Okay, very first week of school, I ran down the 5 steps for solving an equation. Okay, we did not do very good. We even had some quizzes over it where all you had to do is just write down the 5 steps. And a lot of you, even on the first week of school, refused to put any effort into that. And it's caused you problems all year long. Okay, well, there haven't been a whole lot of equations in geometry, but I guarantee there are tons and tons and tons of them in Algebra 2. You will have no success in Algebra 2 if you cannot solve an equation for yourself. Okay, well, the 5 steps I gave you at the beginning of the year, they were already dumbed down at that point, kind of as far as I thought as I could dumb them down. But I spent some time working on it again this morning, and I was able to dumb them down even further than that. Okay, but here we go. Okay, the first thing you've got to pay attention to on any equation is the possible existence of parentheses. Okay, before on the 5 steps, I used to say that eliminate any restrictive items. Well, there are more restrictive items in mathematics than just parentheses, but at this level, mostly what we run into is parentheses. If they exist, we have to deal with them. Okay, the second step. Okay, it used to say combining like terms on the same side of the equal sign. I boiled it down even further than that. Just said combine like terms. Okay, combining like terms is not a difficult step, but we're not very good at doing it, which means either we do not know when we can or cannot combine like terms, or we don't understand how to actually do it. Okay, so we'll talk about those, both of those little situations here in a moment on combining like terms. Okay, I used to say move all your variables to one side of the equal sign. I'm going to just take it even further than that. I'm going to say variable goes one way. Now in geometry, that's been pretty easy to identify what the variable is, but if you remember back to Algebra 1, we had more than one variable in the problem at a time anyway, particularly on like equations of lines or equations of parabolas. You had x's and y's running around in there. On step 3 here, you're only going to be interested in one of the variables, solving for x, solving for y, whatever the problem's got you doing. But whichever variable it is that you're after, we're going to send it one direction or the other. Okay, it does not care which direction it goes. It'll be up to you to decide that. Okay, but whichever direction you want it to go, send it that direction. Okay. On step 4, I used to say isolate the variable. I'm going to even condense that even further now. I'm going to say in step 3, if you set the variable one direction, then on step 4, you're going to send everything else the other direction, whether that is other variables or constants or whatever. Okay, in 3, the variable that you're after goes one way. In 4, everything else goes the other way. And step 5 is about as simple as I can get it to be to begin with, so it still says the same thing that it said at the beginning of the year. Get your 1 and 1. Okay, 1 and 1 refer to the variable, and that is talking about its coefficient being a 1 and its exponent being a 1. In that order, we get the coefficient to be a 1 first, we get the exponent to be a 1 as the last step. Okay. Now, for years, I've kind of labored to come up with some kind of a goofy little acronym or saying or something like that to help you remember the steps, something like, please excuse my dear Aunt Sally, that we've all had etched into our brains at some point in time. Based on these words, I actually did come up with something. So if you like silly little ways to try to remember stuff, well, I came up with a silly little way. You can invent your own. Little acronym I came up with was parents' complaints vary for everyone. Okay, parents' complaints vary for everyone. And if you can remember that, then if you look at it like not necessarily the prefix, but the first few letters of each of those words match up with the first few letters of the step that's involved there. So parents, P-A-R. Okay, P-A-R for parentheses, pair. Okay, parents, parentheses. Okay, complaints, C-O-M, complaints, combine. Parents, complaints, vary, V-A-R, third step, V-A-R. Talking about the variable going one direction. Had to stuff a little word for in there to make the sentence make sense. Okay, but every, okay, that's everything else. Okay, everything else goes the other way. And 1, that's your 1 and 1. Okay, so if you like silly little ways of remembering something, then maybe spend 60 seconds repeating this thing over and over in your head. Guys, we have got to, no matter how you remember it, we have got to get a procedure burned into our brain of how to solve equations. Okay, if you get the procedure wrong, it's not going to matter. You're not going to dumb luck your way into any answers. You're not going to accidentally arrive at the correct answer, because if you can't follow the procedure correctly, you are changing the problem. And if you're changing the problem, you're never going to get the correct answer. Okay, so parents' complaints vary for everyone. Anyway, if you can follow those 5 steps while following the rules that we already know, we can solve most equations. I'd love to be able to say that we can solve all equations, but it's not necessarily the case. You're going to get to some higher level stuff eventually, especially those of you that may have what we call a mathematical awakening. Okay, some people roll along and then at some point in time it just clicks. They just get it. Suddenly we went from struggling with math to really being able to grasp it. We see it better, and it's possible that some of you may end up getting onto a faster track. You may go further than Algebra 2, in which cases we may run into some equations that these 5 steps maybe don't tell the entire story, but you can worry about that when you get to it. Okay, so moving on. it talked about other rules. If you could follow the 5 steps while following the other rules that we already know. Well, the question very quickly becomes, all right, what are these other rules? Maybe those are the reasons that I'm struggling so badly with solving equations. And maybe you're right. Okay, so let's take a look at some basics. First thing I'm going to do is I'm going to warn you off again. The main thing we are doing wrong is we've got too much time with the calculator in our hand. Okay, and that should be readily obvious to you. When I told y'all the other day, here's this quiz and I want you to take it without the calculators, I mean, you could hear the groans and the grumblings, even with as small as the numbers were on those quizzes and as easily workable as some of those equations were. Some people were right off the bat going, oh my gosh, I got to subtract, I got to do 2 minus 4 without a calculator. Okay, we are going to our calculators way too much for way too simple a stuff. And the problem is we are doing it thinking that the calculator is helping us. Okay, well, I got bad news for you. The calculator isn't helping you. It's hurting you. If the calculator is becoming your replacement for knowing math, okay, I would never recommend to anybody that they drop out, but I will tell you this. If the calculator has become your replacement for understanding math, you are getting yourself into a spot where it is going to be virtually impossible to ever graduate. You had better get back to a point where your brain overpowers the calculator, because like I've said over and over again, the calculator is only as smart as the person that's holding it. Okay, when you get to Algebra 2, if you do not understand what you are supposed to be doing, then the calculator cannot understand what you are supposed to be asking. Okay, and unfortunately, we think about that calculator as it's a little box that has God in it, and God knows the right answer, and God's going to give us the right answer, and we should never question God. Well, I'd kind of disagree with you. I think there is a deity in that calculator, but I don't think it's Jesus Christ. I think it's Hades. Okay, and that calculator is evil. Okay, we need to understand what it is that we are asking the calculator to do. And if we can't understand that, then we're not going to get the right answers. Okay, so put the calculator down. If it was meant to think for you, it would certainly do a better job of thinking. Our calculators are stupid. The problem is we think they're smart, okay, and they're not. Okay, but back to the problem. Parentheses, step number 1, parentheses. I think everybody understands when we see parentheses, parentheses most of the time designate that the distributive property is coming into play. The distributive property is going to have to work if we are going to be able to get away from the parentheses. I think we're pretty good at understanding that, which means what on earth is it that's causing us problems? If we understand that we're supposed to do the distributive property, then why aren't we getting it done correctly? Okay, well, again, I think everybody understands what the distributive property says, and here's kind of the long version. Distributive property says if you have one value or a polynomial that needs to multiply by another value or polynomial, then the boiled down of it is everything from the first polynomial or value needs to multiply by everything from the other value or polynomial. So in short, everything from the first times everything from the second. And we've seen this a number of times for a number of years now. Okay, most of the time when we see it in equations, it looks like this. You have a value that multiplies by a set of parentheses. Okay, and that value, in this case this 5, needs to multiply by everything that comes inside of those parentheses. We are very good at knowing that this is a 5 times an x. We are very good at that. Then we are terrible at multiplying the 5 times the y and multiplying the 5 times the -3. We distribute to the first term but not all the other terms. You absolutely cannot do that. Distributive property will not allow it, and if you mess that up, you will not get the right answer. You have changed the question, and now you will get an answer that matches the wrong question. Okay. If we end up with a set of parentheses like this second case, we have a binomial times another binomial. If that's the case, then that's fine. Every term from the first one needs to multiply by every term from the second one. So that A is going to distribute, and it's going to hit every term that it can find out in the second polynomial. And once A is done, then we'll scooch over and we'll use the next term, and it will multiply by every term it can find, and we'll scooch over, and that'll multiply times every term it can find. And you will do that until you run out of terms in your first polynomial, and you cannot quit until you're done. On the right side over there, we see we have fractions. The only thing that fractions change in a problem is every numerator, okay, from the figure on the left needs to multiply by every numerator from the figure on the right. Every denominator from the left needs to multiply by every denominator from the right. Okay, so having fractions in the problem is kind of like a little distribution problem in the numerator and then a little distribution problem in the denominator. Okay, so hope we know that. Now combining like terms. Okay, this is not a difficult idea, which means we must be misunderstanding something about it. Okay, when are terms actually considered to be like terms? Okay, now first off, guys, with something like distribution, which is a multiplication issue, you have to understand multiplication and division is very not picky. Okay, you can multiply just about anything times anything else. You can divide just about anything times anything else. Yeah, you've got laws of exponents and stuff like that we have to worry about, but the multiplication and division most of the time can be done. Addition and subtraction, completely different issue. Okay, multiplication and addition and subtraction is mostly what we see when we're working our equations. And there are absolutely three conditions that must be met if you are going to add and subtract two terms together. Okay, hopefully we know those, but here they are. First off, you have to be looking at the same variable or the same group of variables. Okay, in short, that's to say that if you want to add or subtract an x to something, the only thing you can add or subtract to it is other x's. If you want to add or subtract a y to something, the only thing you can add or subtract it to is other y's. If you have a number, the only thing you can add or subtract to a number is other numbers. Okay, if that does not present itself, then you do not perform that operation. If you have x plus y, those are not the same variable. They will not combine by addition and subtraction. So as a result, you leave them alone. The x will stand by itself. The y will stand by itself. They will not combine. As you move further into Algebra 2, the second thing will become more of an issue. Okay, the variables. Okay, whatever variables you've got, they must have the same exponents if they're going to add or subtract with each other. So it's more than just having an x and another x. It has to be like x to the first with other x to the firsts, y squareds with other y squareds. The variables must have the same exponent. Okay. If it doesn't have that, you do not do it. Probably the closest thing to an example you have of that is hopefully in Algebra 1. You're supposed to work on some quadratic equations. Okay, in which case you had x squareds, you had x to the firsts, and you had constants. The x squareds and the x to the first did not add or subtract with each other. And the reason they didn't was because of b right here. They didn't have the same exponent, so they could not add. C is probably the thing we've run into the most over the years. We haven't seen a whole lot of it here lately, but it's been present for a long time. If there are fractions present, then your fractions must have the same denominator in order for those two terms to add up. Now, A and B, there's not anything we could do about A or B. If the variables didn't match up, we couldn't fix that. If the exponents didn't match up, we couldn't fix that. But if you don't have the right denominators, we can fix this. We can change denominators. We can multiply a fraction's numerator and denominator by a particular number in order to change it. So we can fix C in order to add it up. Now, where we go wrong, guys, is I think is right down here at the very end. I don't think, okay, those three things, those 3 points, A, B, and C, I don't think that those are too difficult to understand. Okay, I think the problem is when it comes time to actually do the adding and subtracting, we don't do it right. Okay, so for example, the one thing I always say is, let's say, you know, I've got two calculators in my hands, and let's say these calculators represent x's. Okay, I've got one x and I've got another x. And if I take these two x's and I add them together, do I end up with a backpack? Of course not. That wouldn't make any sense whatsoever, right? Okay, but we do the same type of thing in math problems all the time. I say 1x plus another x, and then y'all say something like 2x squared. Well, how did the calculators become a backpack? Okay, that's the same idea. What is x? It's whatever it needs to be, right? What is x squared? It's whatever it needs to be. Can it just change what it is in the middle of a problem? It can't do that. So if you're adding together calculators, you better end up with calculators, which means x plus x is not 2x squared or anything like that. It's just 2x. Okay, so when it comes down to it and you've got to do the math here, all you have to do is combine the coefficients. After you clear those three hurdles, just add up the numbers. Keep the variable, keep its exponent. It should not change when it comes time to actually do the adding and subtracting. Okay. Now 3, 4, and 5 won't take us nearly as long to get through as 1 and 2 did because 3, 4, and 5 operate on exactly the same level with each other. Okay, and what makes 3, 4, and 5, which is the variable going one way, everything else going the other way, and then getting your 1 and 1, what has all these three guys doing something in common is these three all involve sending stuff from one side of the equal sign to the other side of the equal sign. All we are doing is rearranging the problem. And in order to do that, there's just two things you got to follow. Okay, two things you got to follow. The first one would be in order to eliminate something from one side of the problem. If you're moving it, that means you've decided it is not where it should be, or it's not where you need it to be. Okay, so to do that, we need to eliminate it from wherever it is. In order to do that, you have to do the opposite of whatever's already happening to it. Okay, if I said I have two x's on one side of the problem, should I add two more x's to get rid of these? That wouldn't make any sense, right? You just end up with four x's instead of two. Okay, so if you wanted to get rid of two x's, you'd have to subtract two x's to the other side. Okay, you do the opposite of whatever the problem says to do. If it's already multiplying, we divide it. If it's already squared, we square root it. Okay, and the reason we can get away with changing a problem like this, eliminating something from one side of the equal sign, is you got to do the same thing to the other side of the equal sign. Okay, remember we talked about the equal sign like a balance. Okay, the problem starts off, the scale is balanced. It weighs the same on each side of the equal sign. If you do something to one side but not the other, if you take something away from one side, well, now the scale tips. It doesn't balance anymore. Okay, so as long as we perform identical operations to both sides of the equal sign, it keeps the equation balanced. Guys, even if you miss part A, even if you do the wrong thing to the equation, as long as you do the same wrong thing to both sides, the problem's still good. You may not be any closer to solving it than you were, but at least the problem is still true. Okay, it's when we do something that changes the truth of the problem, well, now it's not going to matter what happens because we're not even working on the right problem anymore. Okay, so if you can do those two things, 3, 4, and 5, take care of themselves. Now, over the years, I've kind of seen a lot of things that we do wrong. Okay, a lot of the stuff that I just put up on the board, if you'll learn it, if you'll take the time to get this ingrained in you, and by ingrained, I don't mean, oh, today's Tuesday, by the time Wednesday gets here, I will have forgotten it. Or this is May, by the time August gets here, I will have forgotten it. This is one of those things that needs to absolutely positively get tattooed into your skull. Okay, like, please excuse my dear Aunt Sally. You've heard it enough, you've seen it enough that everybody can spit it out. Okay, we kind of got to get to that level with this as well. We just need to be able to spit it out. Okay, but a lot of those things I've told you address a lot of the problems. Now, here's kind of the next level of problems, and you should have some idea on some of these questions here. Will you need all 5 steps for every problem? Okay. Well, a little bit yes and a little bit no. Will you need to think about all 5 steps for every problem? Yes. You absolutely need to think. Step 1 is to do this, step 2 is to do that, step 3 is to do that, and all the way through. But the reality of it is not every problem is going to need all 5 steps. Okay? How do you know which steps it's going to need? You won't. That's why we think about all 5 of them in the right order. Okay? But in most cases, most of the time, most problems only need 2 or 3 of the steps in order to get through it. You won't know which ones it is until your brain gets trained a little better, okay? But until then, think about them in order, try to perform them in order to get through the problem. Okay? Next, will you ever see things in a problem that are not mentioned in the 5 steps? Yes, you will. Okay? The problem with dumbing things down like I've been doing, okay, that 5 step that we gave on the first slide, the problem with narrowing it down or making it as general as that is it doesn't talk about everything that could possibly happen. Okay? Especially, we get toward the end of Algebra 2, you're going to learn some new operations. Okay, some new math that's out there, and y'all don't know how to deal with it yet. Okay, and if you go into pre-calculus, again, there are other things in these equations that you have not been exposed to yet. So yeah, there are things that are out of those 5 steps that are not showing up in the 5 steps. But as you learn them, you should pretty easily be able to figure out where does that fit in with the 5 steps that I have. Okay, parentheses. Is that the only type of restrictive device that's out there? There's all kinds of stuff out there. Okay. But anyway, so yeah, you will see things in the problem that the 5 steps don't talk about. Will everything I see in an equation have an equal opposite so you can move it to the opposite side? Right now, things are really very simple. If something's being added and you don't like it, you can always subtract it. If something's being multiplied and you don't like it, you can always divide it. It's really very simple. But the question very quickly becomes, as I get to this new math that you're talking about, does all of this new math have a counterpart? Is there something that will negate whatever it is that you've got in the problem? Okay, and the answer is yes and no. Okay, most everything in math has an equal negative part of it: addition and subtraction, multiplication and division, stuff like that. But as you get into the higher and higher maths, you're going to find that some of this stuff is a little bit more tricky. Okay, and it may not come with an exact opposite to it. But what you'll also find at that point in time is you will learn how to deal with that. What happens if this operation doesn't have an exact opposite? Oh, if it doesn't, here's how you treat it. Okay, so yeah, there's not always an opposite, but we will learn how to overcome that. How do you know if you get the answer right or wrong with solving an equation? Okay, well, this is the old fail-safe, and we say check it. Okay, but I've kind of come to believe that some people don't even know what that means or how to do that. The equation is balanced at the beginning of the problem. Okay, it is equal on both sides of the equal sign. When you get all the way through to the end of the problem, it ought to still be equal. It ought to still be balanced. Okay, and we can find that out by taking whatever value we got, plugging it back into the problem. If it still balances, it's good. If it doesn't balance, then we've got a bad value in there. We need to go back and fix it. Okay, so a little bit of review, kind of reworded some things here for you. This is what our week's going to be like. We're going to work on solving equations, single step, simple problems. We're going to get to multiple step, more complicated problems, and by the end, I expect us to be solving some equations. So if you have problems with solving equations, you need to put some time and effort into it on this week. We're going to have a test on Friday, or at least a major quiz, maybe a quiz that counts twice or something like that. But we need to get this solved. Your chances of being successful and getting a high school diploma before this is all over may very well depend on whether you ever figure out how to solve an equation. Okay, so there's an assignment that goes with this. I expect us to get this assignment done this evening. It is not a bring it back tomorrow and you'll have time for it in class or anything like that. So have a look at that.